Good morning, students. This is next topic, that is formulas. There are some formulas regarding Bohr's concept. Three formulas are there. First one is radius, second one energy, and third one velocity. There are some problems based on these formulas. That is why we have to discuss these formulas. We have to learn these formulas. See, I discussed already in previous video. This is nucleus. These are orbits. These circular paths are called orbits. Suppose if electron is present in first orbit, this is first orbit, it is having some energy, and also it is having some velocity, and it is also having some radius. But if the electron is present in second orbit, then also that electron having energy, radius, and velocity, but this energy, velocity, radius is not equal to the electron present in first orbit. That means in every orbit electron having different energies, different velocities, different radius. That is why we have to know the radius and energies and its velocities. Suppose when electron is present in second orbit, what is the energy of the electron in that orbit? If electron is present in first orbit, what is the energy of the electron in first orbit? We have to face such type of questions. So for that, the formulas are En equal to, this is energy of the electron in nth orbit, En equal to minus 13.6 by n square into z square electron volts per atom. This is the formula to calculate energy of the electron in nth orbit. Nth orbit means if it is present in first orbit, then we have to put n value 1. If it is present in second orbit, then we have to put n value 2. If it is present in third orbit, we have to put n value 3. Like that we can find energy of the electron in any orbit of an atom. And Z is atomic number. N is orbit number, Z is atomic number. This is the formula regarding energy of the electron. And radius of the nth orbit, that is 0.529, almost 0.53 into n square by z angstroms. Radius is measured in angstroms. And velocity of the electron formula, velocity of the nth orbit equal to 2.18 into 10 to the power of 6 into z by n meter per second. In centimeters, 2.18 into 10 to the power of, in centimeters, 2.18 into 10 to the power of 8 into z by n centimeters per second. This is the formula in meters, this is the formula in centimeters. We have to learn these three formulas. These three are very important formulas. So here radius of the nth orbit, that means if electron is present in first orbit, what is its radius? That means 0.529 into 1 square by z means atomic number. If electron is present in second orbit, what is the formula? 0.529 into 2 square by its atomic number. So like that we can find the radius of the orbit, radius of any orbit of an atom. In case of velocity also, if electron is present in first orbit, its formula, its velocity is v1 equal to 2.18 into 10 to the power of 6 into its atomic number by 1. In case of first, in case of second, by 2. So like that we can calculate energy, radius, velocity of the electron in any orbit of an atom. Next, here we have to know one more point. The first point is, see, if you see velocity, if electron is present in first orbit, its value is 2.18 into 10 to the power of 6 by 1. Suppose if it is hydrogen atom, then it value 1. If suppose electron is present in second orbit, then its velocity is 2.18 into 10 to the power of 6 by 2. So take same hydrogen atom. So what is the point compared to here? Here velocity is less. That means if n value increases, nothing but orbit number increases. If n value increases, then velocity decreases. That is the first main point, important point. Next one, in case of radius, if orbit number increases, see orbit number, between orbit number and radius directly proportional is there, so that if orbit number increases, then radius increases. So if orbit number increases, radius increases. What about energy? See here, if minus 1 is not there, then between energy and orbit number inversely proportional. But here minus is there, so that it will be directly proportional. Between what? Energy and orbit number. So here also energy will increase. I will show one example. Suppose E1 minus 13.6 by 1 square. Take hydrogen atom. So finally its value minus 13.6. In case of U2 minus 13.6 by 2 square. Take same hydrogen atom. So here minus 13.6 by 4. So almost its value is so much, minus 3.4 electron volts. This is minus 13.6 electron volts. This is minus 3.4 electron volts. Here you can observe one point, that is here negative value decreases. That means positive value increases. That means as orbit number increases, energy also increases, like radius. So what is the point? What is the statement? If orbit number increases, radius and energy increases, but velocity decreases. That is very important point. Next, one more point is there. Sometimes in numericals, energy mention, there is a question that in that one, calculate energy in joules, calculate energy in ergs, calculate energy in calories. Sometimes we may face such type of questions. So what we know what energy is in electron volts per atom. Then in such cases we have to convert these dimensions. So 1 electron volt per atom equal to, see here, 1 electron volt per atom equal to 1.602 into 10 to the power of minus 12 erg per atom. That means if you multiply electron volt by this value, then that value in ergs per atom. If you multiply this value by 1.602 into 10 to the power minus 19, then that value in joules. If it is multiplied by 93.46 value, then that value in kilojoules. So what we have to know? You have to learn all these conversions. 1 electron volt per atom equal to 1.602 into 10 to the power minus 12 erg per atom. In case of joules, 1.602 into 10 to the power of minus 19 joules per atom. In case of kilojoules per atom, 93.46. That means 93.46 kilojoules per atom. This is joules. This is kilojoules. In case of kilocalories, 23.04 kilocalories per atom. See here one more point is there. This is not here. Kilojoules per mole. This is kilocalories per mole. This is correct it. Here X per atom, joules per atom. Here kilojoules per mole, kilocalories per mole. So you have to learn these formulas as well as these conversions. Then only we will able to write solve numericals regarding this topic. Next, there are some more numericals. Some more formulas. They are, see, in previous video I discussed about hydrogen spectrum. See, all these are what? Spectral lines. I told you at that time, that is, each spectral line having some energy, automatically it will be having some wavelength. See, if suppose consider this spectral line, it is coming from which level? It is coming from third level to second level. That means it is having N2 is the lower energy. That means N1 is 2 and N2 is 3. So this for this spectral line there is some energy, wavelength and wave number also. Similarly, not only for this line, for every line there is energy, wavelength and wave number. To find wavelength, wave number and energy of the spectral line, there are some formulas. They are see, this is the formula to calculate wave number in nu bar. This is nu bar. This is the formula to calculate wave number of the spectral line. Nu bar equal to 1 by lambda, that equal to rz square into 1 by n1 square minus 1 by n2 square. So what is the statement? The wave number associated with the spectral line having lower energy and higher energy. So where n1 is lower energy and n2 is higher energy, we know that z is atomic number. Here one new term is there, that is what? R, that is Rydberg's constant. Its value is 109,678 centimeter inverse. Where nu bar is wave number, lambda is wavelength. Between nu bar and a wavelength, inversely relation is there. So this is the formula to calculate wave number of the spectral line having lower energy and higher energy. Then this is one more formula, that is this is the formula regarding wavelength. This is wave number. Between those two, inversely relation is there. So lambda equal to automatically 1 by rz square into 1 by n1 square minus 1 by n2 square. Finally we get n2 square into n1 square by n2 square minus n1 square. 1 by rz square into n2 square into n1 square by n2 square minus n1 square. This is the formula regarding wavelength of the spectral line, where 1 by r value equal to 912 angstroms. In nanometers, its value is 91.2 nanometers. Next, frequency. The frequency associated with the spectral line having lower energy and higher energy level frequency. This is the formula regarding wavelength. This is the formula regarding wave number. This is the formula regarding frequency. Frequency nu equal to c by lambda. Nu equal to c into 1 by lambda. 1 by lambda nothing but we substitute this value here. Then we get the formula regarding frequency. So this is the formula regarding frequency of the spectral line having lower energy, higher energy. This is the formula regarding wavelength of the spectral line regarding wavelength of the spectral line having lower energy and higher energy. This is the formula regarding wave number of the spectral line having lower energy and higher energy levels. These are the formulas regarding what? When the electrons present in second orbit or third orbit or any orbit. If you want to find radius or energy or velocity, then in such cases we have to apply these formulas. But when the electron jumps from one orbit to higher orbit, if you want to find the energy, wavelength, frequency, then we have to apply these formulas. Then what is the formula of energy? Energy equal to h nu. This is the formula regarding Planck's quantum theory. Actually all these theories are there in previous year, but this year this syllabus is not there, so we didn't discuss about Planck's quantum theory. This formula came from that theory. E equal to h nu, and h into nu value is how much? This is the nu value. Its value is how much? C r into z square into 1 by n1 square minus 1 by n2 square. So this is the formula regarding energy of the spectral line having lower energy and higher energy. So there are 4 formulas. If you learn this formula, automatically you can learn these 3 formulas, because all these formulas can be obtained from this one. Next, now we will discuss about numericals regarding this one. These are the numericals regarding Bohr's concept. What are the frequency and wavelength of a photon. Photon means radiation emitted during a transition of n equal to 5 to n equal to in hydrogen spectrum. That is the question given. So what is the meaning of the question? When electron jumps from fifth orbit to second orbit, that means higher orbit to lower orbit. What I said, when electron jumps from higher orbit to lower orbit, energy will emit in the form of radiation. Here that radiation nothing but photon. Then what we discussed, then spectral lines will form. What we have to find here, we have to find frequency and wavelength of that spectral line. That is the meaning of the question. So what is the formula regarding frequency? Frequency nu equal to CR into Z square into 1 by N1 square minus 1 by N2 square, where C is called velocity of light. It is constant. Its value is 3 into 10 to the power of 8 meter per second. ORR 3 into 10 to the power of 10 centimeters per second. That means this is the value in meters, this is the value in centimeters. So you can take any value while solving the problems. Suppose if you consider centimeters value, then automatically all values should be mentioned in centimeters, same dimensions. So here you can take centimeters value, automatically R value also should be mentioned in centimeters. We know already R is what? Red bus constant. Its value is 109678 centimeter inverse. So we can take this value directly. We can write here this value like this, 1.09 into 10 to the power of 5. Both are almost same. Why we used to write like this? Because if you write like this, then we can solve the numerical very easily. Next, hydrogen spectrum, that means hydrogen atom, so that Z value is 1. And what is the value of N1? N1 always indicates lower energy, N2 is higher energy. So N1 value is 2 and N2 value 5. If you solve all these things, then we can get the frequency. After finding frequency, we can find wavelength. Between frequency and wavelength, one relation is there, nu equal to C by lambda. From this relation, we can find lambda, or you can apply a direct formula, lambda equal to 1 by R Z square into N2 square into N1 square by N2 square minus N. So that means this is the formula, lambda equal to 1 by R Z square into N2 square into N1 square by N2 square minus N1 square. If you substitute all these values in this equation, then also we can get lambda value. Or if you use this formula, then also you can get lambda value, where 1 by R value is so much here, 912 angstroms or 91.2 nanometers. So that is the way to solve the problems. Next, one more model. Calculate the energy associated with the first orbit of He plus. That means when the electron is present in first orbit, in case of He plus, what is its radius? That is the meaning of the question. Here we no need to find radius of the spectral line. When electron is present in first orbit, what is its radius? That is the meaning of the question. What is the radius and what is its energy? What is the formula for radius of the nth orbit? Radius of nth orbit Rn equal to 0.529 into n square by z, where n is which orbit of first orbit, that means n value 1, and z is atomic number. Here helium atomic number how much? 2. If you substitute this value, then we can get radius of the orbit. Suppose if you want to find energy for this question, what is the formula for energy? En equal to minus 13.6 by n square into z square, where n value is 1 and z value is 2. Then we can find energy of the electron. Here I have to discuss one more point, one important point. In energy formula, negative sign is there. That indicates that energy releases, but not energy is negative. So energy is always positive. This negative sign indicates energy releases. So you have to remember that point. So there are some conversions here. These are very important regarding competitive level. 1 angstrom equal to 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. That means this is the value in centimeters, this is the value in meters. 1 nanometer, 10 to the power of minus 7 centimeters, 10 to the power of minus 9 meters. 1 picometer, 10 to the power of minus 10 centimeters, 10 to the power of minus 12 meters. 1 micron, 10 to the power of minus 4 centimeters, 10 to the power of minus 6 meters. All these conversions are very important regarding competitive level, because in competitive level sometimes wavelength will be given in angstroms, and in such cases we have to find wavelength in nanometers. So to solve such type of problems, these conversions are very very important. Next, in textbook there are some more numericals regarding Bohr's constant. You can find those numericals by using the formulas. If you have any doubt, I will clear your doubts regarding